Okay, I think it's recording, but we'll see. All right. So the first problem says 200 milliliters of a 0.02 milliliter of hydrobromic acid is mixed with 350 milliliters of 0.15 molar lithium hydroxide. So the first thing we have to do is write the net ionic equation and then find the pH of the final solution. Okay. Now we assume that the volume are additive, which means we're adding volume together, right? So there's a volume from one of the acid and the volume of the base. So we know the first one is, we know this is hydrobromic, and we know hydrobromic is a strong acid, okay? So we know hydrobromic is a strong acid, so that's basically HBr, and lithium hydroxide is a weak base. So when we write sodium hydroxide and hydrobromic, what happened is the Br and the lithium will become spectators, because remember, the HBr will dissociate completely to H+, and the lithium hydroxide will dissociate completely to OH-. Thus, we're going to basically make water in this case. All right? So what's going to happen is we now need to know what the reaction is going to be. So I know I have 200 milliliters of 0.02 molarity bromic acid, right? H, okay? So that means I have 0.2 liters multiplied by 0.2 molarity. Okay, so that basically is 0.04 moles of the H+. On the lithium hydroxide, I have 0.350 liter, that's from the 350 milliliters, and 0.15 molarity of that. So if I take the volume and multiply by the molarity, I will have the mole. So this is 0.053 moles. Okay, so now the reaction takes place, and the reaction is a 1-to-1 ratio, isn't it? So when that happens, then that means I'm going to subtract this much, because this is the lesser of the amount, correct? That means this is going to be your limited. If I use 0.04, that means there's no more H+, then I have 0.04 here also, and so basically I have no more H+, but now I have an excess of 0.13, 13, okay, moles of the hydroxide left over, basically, right? So because of that, I now can figure out what the pH is. So the pH of this, but I don't have any H's, so I'm going to go pOH of this. So pOH, which is equal to the negative log of the concentration of the OH-, okay, which is equal to basically negative log of the 0.013 moles. Oh, I'm sorry. Go back. That's wrong. I'm ahead of myself here. Okay, so I'm ahead of myself. So go back to the 1,3. Now, this is moles, isn't it? Yeah. Okay, but remember, the pOH is equal to the negative log of the concentration of the OH-. Well, this is not a concentration. This is just a mole. So I have to change this into concentration. So remember, to change that to concentration, I have to take 0.013 moles and divide it by the volume that is there. Now remember, the volume is additive, which means I have 200 milliliters and 350 milliliters. That's basically 0.200 plus 0.350. Okay, that's going to be my liter. And when I do that math, I should have 0.024 molarity, right? So now, since I have that, I can plug it into the pOH, which is negative log of 0.024. And when I do the math, I will have basically 1.62, 1.62. Okay? Now remember, this is the what? The pOH, but we don't want the pOH, we want the pH. So I know that the pH plus the pOH should equal 14. So that means the pH is equal to 14, subtract the pOH, which is equal to 14 minus 1.62, which is equal to 12.38. Okay, so I have written the net ionic equation right there, and I have found the pH of this solution right there.